And our last ones, we're going to look at some more on the shorthand notation. We've got Te, or tellurium, and tellurium has 52 electrons. And if we go up one row and all the way to the right, we're going to find out the electron configuration that we're going to substitute in, the noble gas that we're going to substitute in for our electron configuration is going to be krypton. Krypton we use because it's the closest noble gas, remember group 18 element, without having more electrons in it. And krypton, it turns out, has 36 electrons. So how do we figure out where we are on this Aufbau chart by writing krypton? Well, krypton on the periodic table is 4 rows down, and it's at the end of the P block. So we're going to stop right here, and after we write down krypton, we've included the electron configuration of everything before that. All right, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then finally 4p6. So when we need to get from our 36 to our 52 electrons, well, let's see how many that is. 52 minus 36. That's going to be, let's see, 16? That's 16. Yeah, 16. 16 electrons. We need to add 16 electrons to krypton to get to tellurium. So we're going to pick up where krypton left off, and after 4p we end up with 5s, and we're going to put 2 electrons in there. S. Been a long day. I'm writing my s's backwards. After 5s, we follow this to get to 4d, and we're going to put 10 electrons in there because we are trying to get to 16 electrons. 10 plus 2 will give us 12, so we've got plenty to go into our 4d, and then we end up with 5p. Trying to get to 16, we're at 12. 12 plus 4 will give us 16, so there's our shorthand notation for tellurium. If we look at NB, let's see, where is NB on the old periodic table? There it is, finally. It was hiding from me. Atomic number is 41. That means it has 41 protons, 41 electrons, but that's neutral. So to find the noble gas we're going to use, we go up one row, all the way to the right, and it turns out that we are going to be at krypton again, our good buddy krypton. So krypton has 36 electrons. We need to add 5 more. So again, we're starting here. To add 5 more, we're going to go from 4p to 5s, and we're going to put 2 electrons in there, and then we're going to go to 4d. So we're still looking for just 5 electrons, so 2 plus what will give us 5? That's right, 3. So our shorthand notation for NB would be krypton in brackets, 5s2, 4d3. And then down here, this one's a little tricky. This one's neptunium. Right down next to uranium, it's got an atomic number 93, which means 93 protons, 93 electrons, and a whole boatload of neutrons. Now, it's all the way in the very bottom of the periodic table. You might go up and all the way over, and you'd encounter that there's no noble gases there. What's going on? Well, those bottom 2 rows that are kind of separated from the bottom of the periodic table are actually continuations of row 6 and row 7. They're going to be kind of shoehorned in there between our S block and our P block. So by going up and over from neptunium, we find out that actually we're going to be looking at radon as our noble gas. So radon has an atomic number of 86. To go from 86 to 93, all we need to do is add, it looks like 7. So radon is 6 elements down, and we're going to pick up where radon leaves off, and this gives us 7s2, and that gets us to 86, 90, 88, and we just need 5 more, and then after 7s we end up with 5f, and we're just going to put 5 electrons in there. That'll get us up to our 93 that we need. So 86, 88, 88 plus 3, or plus 5 will give us 93.